So I'm Andrés Navarro from NUAVIS, and I'm going to talk about artificial intelligence and about deep learning in particular, and how to apply it to the agricultural and food sector. So nowadays, agricultural and food industries are facing great challenges, from population growth and its related rise of animal protein consumption, to climate change and the decline of arable land. Those challenges involve the transformation of the farms to become smaller, smarter, more productive, and digitalized. Artificial intelligence can be a strong ally on this task. Artificial intelligence takes form in multiple types, from functional to analytic, visual, textual, and interactive AI. Each of them with their corresponding technologies. And I'm going to focus on computer vision, which is the technology that on NUAVIS we work on. Computer vision, which allows a computer to understand an image and extract valuable information from it. So in the next minutes, I'll be covering how computer vision has evolved in the last decade and how can we apply it to the sector. So as I said, computer vision has rapidly evolved in the last decade, starting from basic image processing algorithms. Computer vision entered the machine learning era so many decades ago. However, it's in the last decade, thanks to the vast amount of images that we have access to and the very powerful and specialized computational devices that we are now surrounded by, which has helped computer vision to make a huge step forward with the popularization of deep learning. I guess that most of you have heard about deep learning, but I'm just going to explain why deep learning has created that big improvement in computer vision. So first of all, can you hear me?
We just lost you for a moment, but was just one second.
Okay, yeah, I was hearing some beeps. Okay, I was saying that first of all, feature extraction engineering is no longer required. That leads us from, I will say, a more handcrafted solution that we previously have to more general purpose solutions. Moreover, deep learning scales very well. It is very easy, for example, to include a new class in a classification problem without the need to redesign the solution. And it is more robust in terms of the quality of the images that we have to capture. And what is more important, in certain complex problems, it allows us to reach an accuracy that was not possible before. So how can we apply deep learning to the agricultural and food industry? I'm going to show you some examples from the literature, because since to confidentiality agreement, I cannot show you in detail any of our examples in these sectors. So the following examples, I've selected them to emphasize certain cases where deep learning has become a great enhancement. So previously, also in other machine learnings, we used to have accuracy levels around 70–80%, which resulted in an almost feasible solution. And now with the deep learning, we can reach accuracy over 90%, becoming a robust solution. So in this first example, the objective is the detection of cucumber defects from a hyperspectral image as source using a convolutional neural network and an autoencoder, which are some types of deep learning implementations. They increase the accuracy from 73% using a support vector machine to 91% using deep learning. In this second example, the objective is to identify rice variety of certain grain samples. Starting again with an hyperspectral image, using again a convolutional neural network, accuracy increases from 79% to 91%. In the third example, the aim is to evaluate red meat quality by detecting any adulteration that the product could have suffered, which involves a safety fault. Using a similar approach than before, accuracy is increased from 87 to 94%. And in the last example, the objective is to classify the terrain into different types of crops and soil using satellite imagery. So from images at several spectral bands during the different periods in time, and using again a convolutional neural network, accuracy is increased from a previous implementation using random forest from 88 to 94%. So how is NUAVIS approach to deep learning and in general computer vision problems? So in NUAVIS, we have collected our knowledge into a set of proprietary libraries. These libraries allow us to develop customized solutions that, first of all, require less training, are very robust to deviations on the images that we capture and the illumination environment, and which their performance has been optimized for different sets of hardware. For example, we have applied our deep learning library to different tasks. For example, to assist a worker in a manual task where we supervise and check that the task is performed correctly, to automate the task by, let's say, being the eyes of the system, to pick up objects in random positions in a container, or to verify the quality of a product. So in conclusion, deep learning is a mature technology that is ready to be applied to many applications. We can achieve with deep learning a substantial accuracy improvement. And although deep learning initially requires a great amount of samples of data, we have different learning techniques that reduce this requirement in many cases. Finally, it's important to remark that a profound expertise is still required for many aspects of the application of deep learning, such as the capture and processing of the data, the design of the architecture, optimization of hyperparameters, and training of the model, as well as the deployment of the solution and its integration with the infrastructure. Thanks a lot. I'll be glad to answer any question.